Okay, so this is just a review of some of the minerals and igneous rocks that you'll be looking at in lab today. So because we can't look at real hand samples, I'm trying to give you a variety of images so you'll have an idea of what these things look like, because certainly we're using our visual observations mostly name these rocks and minerals. So there's a few tests we can do, but starting out with the minerals, and of course we talked about we're not investigating all of the minerals, we're investigating just a handful. So ones that are pretty common, rock forming minerals, or ones that have an impact on some of the hazards we're going to discuss. So certainly we talked a little bit about quartz, and so it has a variety of forms and colors. But remember, one of the diagnostic features of quartz is that it breaks in a weird fashion called conchoidal fracture, which means it doesn't really have any cleavage. It also is a mineral that you cannot scratch with a steel nail, which would be a test we would do if we were in the lab. And so that's a good diagnostic feature of quartz. We also have MUSCOVITE and BIOTITE, which are very similar minerals. They're in a group called micas, but the difference here is the colors. So you can see BIOTITE is generally black in color. MUSCOVITE has this kind of silvery tinge to it. The diagnostic feature of these minerals are that they're cleavage in one direction. They have these thin sheets you can peel apart, and so that is a diagnostic feature, that they have that one direction of cleavage. And to differentiate between them, we would use color. So remember, color is still useful for us, especially when we talk about igneous rocks. And then we also talk a little about halite. Some diagnostic features of halite is it's cubic. Of course, it also tastes like salt, though usually that's not the recommended way of identifying halite. We also have calcite, which can look and be easily confused with halite, because it almost looks cubic, but it's really rhombic. It's kind of a squished cube. But the big deal about calcite is that it reacts with a weak hydrochloric acid solution, which is one of the major tests we do. So it looks something like, as I bring this over for you, something like this, where we put a little acid on it and it would react, bubble or fizz like that, and that would be an indication that you have calcite. So it's a great little tool for that. And of course that works for some rocks that are made up of calcite. Alright, let's see. And then what else do we have here? We have gypsum that we're going to look at. Gypsum super soft. So one of the diagnostic features of gypsum is that you can scratch it with your fingernail. So that's very useful because we of course have our fingernails with us, and that can tell us something about what mineral we have. And then of course there's a few others that we talk about, plagioclase, feldspars, and we talk a little bit about pyroxenes. So we'll look at those minerals in lab also. And some of these minerals that we're talking about are very common in our igneous rocks. Others are ones that are useful when we talk about certain hazards like gypsum and calcite and things like that. So remember that we are looking at igneous rocks also. And so there's really our two forms of igneous rocks. We have either volcanic rocks, or we could use the term extrusive, right? So they're interchangeable, means that the rock made it to the surface. And then we have intrusive or plutonic rocks, which means the molten material cooled at depth. And because we separate those, we see that they have different textures. Because the big deal about igneous rocks is, in order to identify them and name them, we want to identify their textures and their compositions, and then we can use a chart to give it a name. So the two main textures that we have are coarse-grained or coarsely crystalline texture. Remember, that's the idea that you have very large crystals that you can easily see with the naked eye. These are all examples of those. And this is telling you that this is a plutonic or intrusive igneous rock. The idea is that the crystals are large because it cooled very slowly. So it's telling us a couple things. One, where it cooled and how it cooled. It cooled very slowly because it had time to do that. And then our other main texture that we look at with igneous rocks is fine grain or finely crystalline igneous rocks, and these are all examples of those where you cannot see the crystals easily with your naked eye. These would all be considered volcanic or extrusive igneous rocks, and they've cooled on the surface, which means they had a pretty fast cooling rate. And so we want to be able to identify these textures, so both the coarse and the fine. And then for this class, we also want to look at what's called vesicular texture. And so that means that there's lots of holes in the rock sample. This is an indication of lots of trapped gas in the magma. So an interpretation for that is the trapped gas. And then we also have what's called a glassy texture. These, once again, are all examples of the glassy texture. And this is just indicating an extremely fast cooling rate, like something is quenched or something. Maybe it flowed out into water or something like that. So once we identify the textures, then we want to look at the compositions. And we said that we can do that by using color. And so we want to look at whether it's volcanic or plutonic, we want to look at some of the color we see. And so the categories that we have for those are felsic, intermediate, mafic, and we even have an ultramafic, though it's not used as commonly. The idea for us in this class is that felsic are rocks that have lots of silica and aluminum. They don't have a lot of iron and magnesium. This makes the rocks very light in color. So if you're looking at a coarsely crystalline rock, you would have a rock that does not have a lot of black minerals, because we're looking at all the minerals, we can see them. So it's a low percentage of black minerals. That's going to help us identify it as a felsic composition igneous rock. And so these are the coarsely crystalline ones, and then of course we have finely crystalline ones that are also felsic. Can't see the crystals here, but because there's not a lot of dark minerals, the overall color is light in color. And so that would help us diagnose this as a felsic igneous rock. And then we could look at some intermediate, and let's jump all the way to mafic first. So mafic is the other end of the spectrum. These are all dark rocks. And so these are coarsely crystalline dark rocks here, but the color is giving us an indication that it's mafic, lots of dark minerals. Or if they're finely crystalline, they look like this, right? So they're very dark in color, once again, because lots of dark minerals. So we have felsic, light, mafic are the dark, and then we're going to have our intermediate. So if they're coarse, right, they're about 40% dark minerals, as opposed to our felsic that might be like, 10%. And then our mafic would be, pushing the 70-80% dark minerals. This is how we're going to identify the composition. And so we of course have the dark, and these are the intermediate compositions that are finely crystalline. And so look, if you were just given this one of these samples here, it might be challenging to determine if it's intermediate or felsic or mafic. This is why in the lab you always have a comparison. So you have a couple samples. The idea is find the lightest, find the darkest, find the one in the middle. This is how you would identify mafic, intermediate, and felsic, right? And so that's what we're going to do for the lab. So I get it. Sometimes if you just were thrown a sample, it would be difficult to ID, but given a group of samples, you should be able to pick out which is which. And then there is another category called ultramafic. These are volcanic rocks that contain a large amount of olivine that you can easily see with your naked eye here. These are thought to be examples of the mantle itself. And so they're not super common, but every once in a while during a unique eruption we can get some of these rocks at the surface. We think they represent what the mantle actually looks like, as opposed to the others that have gone through some process of change as they make it to the surface. So with all those things in mind, you can then identify and name the type of rock you have. Because what we're going to do is just look at a chart that tells us the composition. So color is our friend here, just using that to help us with telling us which one we have. And like I said, we'll give you a group or a comparison so you can say, oh, the light, the dark, the intermediate. Then you know which column it goes into, and then depending on its texture, you either have a granite or a rhyolite, a diorite or andesite, a gabbro or basalt. So the basalt, andesite, and rhyolite are all the finely crystalline rocks, and the other three are the coarse. And you can see that their compositions change when it comes to the amount of minerals that contain in each rock. Over here in mafic, we have minerals rich in iron and magnesium. This is what's giving the minerals the dark color, and if you have a lot of dark colored minerals, you get a dark colored rock. Over here on the left, not many minerals that contain iron and magnesium, so not many dark colored minerals, so overall the rock is light, and then voila, something in the middle. And of course for us, we're going to use this chart, which has a little more information on it than we really need, but that's okay, because we're not going to look at pegmatitic or this porphyritic texture. We're just going to focus on the coarse and the fine, are the two main groups. So it still works the same. You look at the color, find which composition category it goes into. You find the texture, and you just go across. So if I determine it's felsic and it's coarse-grained, it must be a granite. If it's mafic and coarse-grained, it must be a gabbro. We do the same for the fine-grained. For the vesicular, we do that also, and even for the glassy texture, which luckily there's really just one name for everything, so that's okay. But this is kind of the process that you'll do in the lab. You'll have some imagery. You're looking for color to give you some information about its composition. You're looking for texture to give you some additional information about where these may have cooled and crystallized. And then with the chart, you should be able to name those rocks. And so that's kind of how the lab's going to go. I don't think it should be too complicated. I try to make it relatively easy, realizing that you're not able to hold on to real live hand samples and we're just looking at pictures. So hopefully this was helpful to get you kind of on par for what you're looking for when it comes to images of colors and things like that. If you need to stop the video on some of the slides so that you can review or kind of get your eye kind of correlated on colors, you can certainly do that.